Hi guys, I'm working on a little project that actually is going to be using a 3.3 volt microcontroller, but it needs external circuitry that's going to be running TTL logic values at 5 volts. And the 3.3 volts microcontroller, of course, is not going to be happy dealing with 5 volt levels, because it could actually damage it and so on. It's a different logic family, and it has to be converted. So which started me thinking, I was actually wondering, this is actually an Arduino UNO, which is running at 5 volts, of course. And I've actually got a little trim pot connected over here to provide input to the 0 pin, D0, whatever you call it. And I've got a little sketch running on there that actually measures the input of that pin, and if the input is low, it'll make that LED low, off, turn it off. If it measures this and decides it is high, it'll turn that on. And I have found that, as you can see on the screen, that around roughly 2.4 volts is what the where the knee is in the actual value. If it is 2.4, a little bit over 2.4 volts, it goes on, and if it is below 2.4 volts, it will actually think it's low and it'll go off. So I wanted to have a look at that. So that tells me that, and I've actually tested that you can actually hook up a 3.3 volt logic level into a 5 volt circuit, and it'll still be interpreted as a high when it comes up with the 3.3 volts, because the 3.3 volts output would be at least 2.5, 2.7 volts or something for a high level. So mostly that means that it would match. So you wouldn't have to do a conversion, therefore, if you're doing a 3.3 volts logic level input into a 5 volts device. So that is one thing. What we actually have is some circuitry. There we go. So this is roughly what we are looking at over here, trim pot. I did put an extra resistor on there to make it less sensitive, but basically that's what it is. I can vary the input from +5 to ground, and I've got it connected to pin 0. Now, the next question is, I've also put a little bit of code in this child board over here, which is like that. This particular one is almost a little bit like a converted blink sketch, really. So we also have the little LED on there that will blink, and we have these pin D0 as output, and we actually just do, like, it's really a blink sketch, but with an extra pin there on D0. Goes high, low, high, low. Okay, so what we're now proving is that when we are dealing with a 3.3 volt device, the output of it is actually acceptable to a 5 volts device, and we can see that it is actually flashing the output. Okay, so we've found out that if we are going from 3.3 volts to 5 volts, we don't have to do anything. The signal can go straight through. That is what we have found out. However, when we want to go the other way, go from 5 volts to 3.3 volts, that's a different story. Then we need to have some device, either a transistor or some other logic in between to convert the voltage levels. So let me get set up over here, and I've got a little sketch in there that actually, I don't know how interesting that is. This is all that's in there. It also outputs on pin 12 because earlier on I was actually wondering how high the voltage level from the Arduino was, and it was 4.9 something volts. It was quite close to 5 volts. So that is all it does. It does a digital read on the pin and sets the LED accordingly to the same level. There are several options for converting these signal levels when you have to, and mostly it is to do with when you are going from 5 volts to 3.3 volt levels, because that's where the danger lies, that the device that is expecting no more than 3.3 volts might get damaged if you provide it with 5 volts. So typically what I use is a open collector TTL devices. There is a whole number of them, but these are kind of like buffers. 74LS07 is the example over here. That's a non-inverting one. There is also a 74LS06, which is an inverting one, and we can look at the data sheets in a minute. But so all you have to do in those cases is you have a pull-up resistor going to the 3.3 volts level, and then you have an output which is compatible with 3.3 volts. And for example, like you might be feeding it into a ESP32 board, like over here. And this device, the 74LS07, of course, itself runs on 5 volts, but it has up to 6 of these buffers in there, so you can use it for up to 6 signals. And in that case, if there is more than one, I tend to use one of these resistor arrays that you can buy, a little strip, so you don't have separate resistors everywhere. It's easier to use, takes less space, which is I've done that as an example there. And the resistor array, of course, will be connected to 3.3 volts. Now, when you have an open collector output, it really means that the transistor that is used to present on the output actually presents its collector to the output, and therefore when I connect a resistor there, you complete the circuit, and that is why you can then hook that resistor up to a different voltage, so you can actually output different voltages from the input. We will see that on the oscilloscope in a minute when we look at the signals. However, if you only got 1 or 2 signals to convert, you might decide to use a MOSFET, which is what is shown over here, which is actually a similar situation. The signal coming into the MOSFET, when it goes high, it turns the MOSFET on. That, of course, connects that point here to ground, because the MOSFET has got low resistance, and then that signal goes low then. So what it actually does is it actually is an inverting output in that case. High here will be low there, low here will be high there. But the principle is the same. You are connected to 3.3 volts to a resistor, so it can never go higher than that. And in that example is at 3.3 volt A. As an example, I've connected it to the D1 pin on an ESP32S3. The only other situation you might come across is if you need bidirectional signals, which can come in and out, which is sort of what this little circuit here does. This is also a MOSFET, and I got that circuit from on the internet, and we'll look at that in a minute. And Adafruit actually does little boards with that circuit on it, so you can get a high voltage circuit, 5 volts level signal coming in, and it'll present it as a low level signal. And these signals, like the I2C, is they are bidirectional, so that would be applying to those. Although some devices, like for instance the 24CXX little memory chips, say I2C, but they can actually work with 5 volts or 3.3 volts levels themselves, so they don't need any conversion. But usually when you're dealing with I2C, you're dealing with some sort of sensors and so on, and some of them may in fact not work at higher than 3.3 volts, and you might have to use level conversion in that case. If you are using one of these Arduino UNOs, if you're using a ESP32, which is 3.3 volts by default already, you wouldn't have to do anything, you can just hook it up. But maybe there are some that need 5 volts, then you'd have to go the other way around. So in any case, this is typically the circuit that you have. Again, it's a MOSFET. It's bidirectional. High voltage can get in, low voltage out. Low voltage can get in, high voltage out, which is kind of shown over here on the SCL line, for instance, and there's an SCL line there. This is the higher voltage one, it's a low voltage one. So that's what we're dealing with. You'll find that various sources, Adafruit for instance, have a whole bunch of these types of level shifters. Here is one that has it's a bidirectional bus, and I think it has something like that on there. The 74LV245A octal bus transceiver, 3-state outputs. So that is another option. That circuit I was showing you with the bidirectional MOSFET here, BSS138, kind of comes from here. I'll put links in the description, and you can actually read all this stuff here, how it works. And again, this kind of thing uses that kind of MOSFET here, and it has something in common with the 2N7000 that I was using. They are logic level devices. This is actually Adafruit's version of it, I believe. There's 4 of them on there. See, 4-channel I2C safe bidirectional logic level converter, BSS138. So you can either buy this little board, or you can put some of those things on your own PCB. Again, 10K resistors, exactly the same. And this is the MOSFET that we are going to be using and looking at. And you will find that this particular one is got a over here gate threshold voltage, VGS. It says 0.8 to 3 volts, but they tend to be, around 2 to 3 volts somewhere. That actually makes this low voltage enough to work as a logic level device, and that's why we can hook it directly up to the output of a Arduino or any of the microcontrollers, and it will work. And the actual device here, the open collector high voltage, they actually mention that you can convert TTL levels to MOS levels, and of course they can handle up to 30 volts at 40 milliamps, and that means that if you got a drive, you can also use this thing to drive something that needs a higher voltage, and so that can be handy as well. The LS06 is also available. It actually has inverting outputs, but other than that, it's the same. Alright, so let's have a look how it might work. Okay, so first off, we have one of these little power supplies here. There's 3.3 volts there, and there is 5 volts over there. So that means that this is the 5 volt power rail, and this is the 3.3 volt power rail, the red ones, and both of those are ground. And we have we'll connect this up over here. these chips over here. You can probably read it if I light it up like that. 06 is over here, 07 is over here, and there is a 2000 and 7000 MOSFET over here. Let's put it at that level. So what we have here is a 1 kilohertz signal in actual fact, and we are looking, the yellow one is the input, and we can see over here that it is just a smidge over 5 volts coming out of the function generator. The pink one or magenta one is actually the output of the 74LS07. So being that it's open collector output, as I said, running connected to 3.3 volts, and it is telling us that it's actually outputting 3.2 volts. So it is doing its job. So now let's have a look at the MOSFET situation. Okay, so now I've got it connected to the output of the MOSFET, and as you can see, it is doing a similar job. Its output is also at 3.2 volts, but it is actually doing the same thing as an inverting output, because the MOSFET, of course, has got a common source configuration, so it actually does it inverts the output. So you've got to keep that in mind, which is similar to if I connect it to this. I've got these breadboards I'm getting from cheap ones from AliExpress, Alagu or something. They are really crappy. You have to wiggle the wires in order to make a good contact. Anyway, this is what we have with the 74LS06. It is also the inverting version. It's doing exactly the same thing as the MOSFET's doing, as you can see. So that's it. This is what you can do if you have to convert inputs and outputs. So as I said, this is the MOSFET over here. This is what we're looking at with the LS07, and if this was a 06, it's exactly the same, but it would have an inverting output, as you saw. So that's it. I thought maybe you'd find that somewhat interesting, and I will see you guys later. Don't forget to subscribe and all that kind of stuff. Bye bye.